Lesson 3, accumulation functions, leading more and more to integrals. Okay, you're going to see the integral here. We're not actually we're going to, I guess, solve integrals in a way. Not, when I think of solving integrals, I think of taking the antiderivative. We're not there yet, okay? Because that's what solving an integral is doing the opposite of a derivative. We're going to do an antiderivative, okay? But we're not quite there yet. We're still learning about the concept of it. So, given some function, f of x is a continuous function on the interval a to b. Suppose we define some function whose area under the curve between point A and some other point x. We can denote the area under the curve as a definite integral. Okay, so again, I keep kind of mentioning that. Area under the curve, that's what an integral is, right? So derivative was slope of the tangent line, and integral is area under the curve. Okay, so we can define this new function, capital F of x. And so this is common notation that capital F of x is the integral from a to x of f of t dt. So that's saying it's the area under the curve from a to x. Okay, so for any value of x between a and b, this new function will give us the area under f of t between a and x. This is fundamental theorem of calculus part 1. So when you see FTC, that's fundamental theorem of calculus, and there's a part 1 and there's a part 2. This is part 1 that we're talking about. Part 2 will come up later on. Helps to make the connection between integrals and derivatives. Every continuous function f of x has an antiderivative, capital F of x. So, fundamental theorem of calculus part 1. If f of x is continuous on the interval, then g of x is equal to the integral from a to x of f of t dt, if it's continuous on a to b, and is differentiable on a to b also, g prime of x is equal to f of x. So the idea here, okay, derivatives and integrals undo each other is essentially what happens. So I mentioned antiderivative, and it mentions antiderivative wherever it was here, okay? Antiderivative and derivative are opposites. The derivative, if you're taking the derivative, the antiderivative is going to undo that here, okay? So when we talk integrals, we're talking antiderivatives. So the idea here is that when you take the derivative of g of x, well, that means you'd be taking the derivative of an integral. When you take the derivative of an integral, a derivative and an integral are going to undo each other, and it's just going to be equal to the f of x there, okay? So there is alternate notation shown here, taking the derivative of both sides. So that is notation we often see there that, notice right here, the derivative of an integral is going to be equal to this function right here. Notice it has the upper limit plugged in there. So when you do the derivative of an integral, and then it's equal to that inside with that upper limit plugged in. And again, we'll look at that as we go, okay? So let's look at some example 1. I think I'm going to be smart here and give myself room to work. And what? Zoom in. I'm not smart like this often enough. If I don't set up, I just don't think to go with it. But yeah, we're going to zoom in. Okay. The graph of f is shown below. I know it's a graph of f because it's labeled the graph of f. We're defining g of x to be the integral from -6 to x of f of t dt. Evaluate each of the following. Okay, so g of -3. What does g of -3 mean according to the stem of the problem up there? Every place you see an x, you're going to replace it with?
From -6 to -3.
The integral from -6 to -3 of f of t dt. Okay, what have I been saying integral is? Yes, but not what I'm looking for in this case. Okay. In terms of a graph, it's going to be the area under the curve. So this one is the area from -6 to -3. Okay, and we say area under the curve. Officially, let me say that is the area between the curve and the x-axis. Okay, so it's defined as area under the curve. Think curve to x-axis. So, what are you seeing there?
Trapezoid.
We could talk two trapezoids. I can't talk one trapezoid. Are you guys with me there?
Yeah.
Because I could talk a trapezoid from -6 to -4.
Yeah.
What did you say, Hannah?
Like the right side, left side. Trapezoid.
Say that again?
Like the right side, left side, right trapezoidal.
Yeah. Yeah. Okay. So, and I was going to do the trapezoid from -6 to -4. Do you guys see that one? So there's a couple different ways. So if I do that, that's, remember your trapezoid is what? 1/2 times the height between the bases. What's the height between the bases? 2. And then times the bases added. What are my two bases?
3.
1 and 3. So 1 plus 3. So what do we have there? 1 plus 3 is 4. Yeah. So half of 2 is 1. 4 times 1. So we agree that's 4 in that section. We also need this other little piece, right? Could you do another trapezoid there?
Yep.
1/2 times
1.
This time it's a height of 1. What are my bases?
2.5 and
3.
3.
And we do know that's 2.5. We're not just guessing. Do you realize why it's 2.5?
No.
Think in terms of your slope. What's this line doing? It's going down 1 over 2. So where would it be right here? It would officially be at the halfway point. Fair enough?
Yeah.
Okay. So half of 1 is half. 3 plus 2.5 is 5.5. So I'm doing half of 5.5, which 5.5 is 11 halves, right? So 11 fourths, which is 2.75. Are you with me there?
Yeah.
So this integral that I was doing, I ended up breaking it up into 4 plus 2.75, and so I'm going to get Are you guys with me?
Yeah.
Okay. B?
-6 to 0.
Okay, so this time I'm doing the integral from -6 to 0 of f of t dt. So what do we already know?
-6 to -4 is 4.
Well, even farther than that, we know -6 to -3 is 6.75. Can we go ahead and use that?
Yeah.
Okay. And then, what do I need here?
And you go to 0.
-3 to 0, what are you seeing?
Another trapezoid.
Yeah, could we just do that as one big trapezoid? We're getting our practice here, aren't we? 1/2 times a height. Distance between the parallel bases is 3. And then the bases are
2.5.
Okay. So half of 3 is 1.5.
Sorry, guys.
I did 3 halves just because I don't have the calculator in front of me. 2.5 plus 1 is 3.5. which is 7/2 in my brain. So I got 21/4, which is 5.25. And I'm not saying you can't use a calculator, okay? It's easier for me to just go that fraction route and convert back. So this is 5.25 right here. When I add the 5.25, are you telling me 12?
Yeah.
So the area from -6 to 0 is 12? Okay. Moving along. Now what are we doing? Okay. The area from -6 to 4, f of t dt. What do we already know?
12.
We already have the 12, which takes us up to 0. Let's see, 0 to 4. Do I have one shape I can look at?
Another trapezoid.
Surprise, surprise. Okay, trapezoid. 1/2, a height of 4 between the bases. Bases of 1 and 5?
Yeah.
So half of 4 is 2 times 6.
12.
12?
24.
So 12 plus 12 is 24? Okay. And almost there. 7. The integral from -6 to 7, f of t dt. I'm guessing you guys are going to tell me to say
Trapezoid.
24 plus. And then,
Or so.
is there a trapezoid here? And it's not that you couldn't break it up into like triangles and rectangles, but on the flip side, I think trapezoid practice is probably good for you, honestly.
And it's faster.
So 1/2, height of 3, heights of 5 and 1. So 3/2 times 6, 18/2, which is 9. I keep double checking my key to make sure we're on the right track here. 24 plus 9 is? Okay.
That's pretty fun.
I will say, there are times, like when we start to put this all together, you guys will get into that, okay, I'm going to find the integral, I'm going to find the antiderivative and do that math there. But I'm going to tell you guys, there are times to recall that, by definition, if you're given a graph, definition is area under a curve. You sometimes don't have the information to integrate something. You have to do area under the curve. So, we've got to get our geometry in there. I don't even know that we used geometry there. That was just middle school math, maybe? How's that? Middle school math. Okay. Example 2. Let f be the graph of the function shown at the right. Okay. So I don't think it ever... that bothers me. That's f of x there. Okay. They never said that f is the, they don't have it labeled. So I'm going to label it.
Is that the fact?
Yes, it would be f of x.
Why not,
Or would it be f of t?
why not g of x? G of x is the bottom graph.
Because in the directions it says, let f be the graph of the function shown at the right. So I guess I probably should have labeled f of t. I get in the habit of f of x.
Because heaven forbid it makes sense with f of x.
But, and you get, honestly, minor detail. F of x, f of t, it's f. That's what matters here, okay? Now, so they're asking us to complete the table below based on this given information here. That g of x, capital G, is the integral from 0 to x of f of t dt. So similar to what we did previously, we're just going to run into a new little piece of information as we go. So, okay, first one, input is 0, and we're being asked to find g of 0, which if you go back up here, plugging in 0, that means it's going to be 0 to 0 of f of t dt. So the integral from 0 to 0. It's 0 because it's the integral from this spot to this spot. It doesn't move. There's no distance between the spots. So what's the area under the curve at that point? It is 0. Okay? Okay. G of 1. The area under the curve from 0 to 1 of f of t dt is 2. Because that is an actual plain old rectangle, and 1 times 2 is 2. Enjoy the easy when we get it, right?
Oh, no.
Okay. Now, oh, I forgot that they quit filling them in. So input is 2. So what are we being asked to find?
G of 2.
G of 2, which is the integral from 0 to 2. Okay. The integral from 0 to 2.
5.
So right here,
It's a triangle?
A trapezoid?
Really?
On the other side. Sorry.
Oh.
Haven't gotten there yet.
I was like, what are you talking about?
Sorry.
Okay, so from 1 to 2, I see a trapezoid. What do we know about that trapezoid? 1/2 times the height of 1 and bases of
2 and 4.
2 and 4. So half of 6 is
3.
3. Now, this is the integral from 0 to 2, so what do I
You
need?
have to add them.
Yeah, this is going to be 2 plus 3, which is 5. Okay. G of 3.
It's a triangle.
So it's 0 to 3. Now I'm with Sophie's triangle. What do we know about triangle?
1/2 of base times height.
1/2 of base times height. So 1/2 times 1 times 4. So that triangle is going to carry an area of 2. And what do we know here?
7.
5 plus 2 makes us at 7. Okay. And now we're going G of 6. So integral from 0 to 6. We already know we're at what? 7. Okay, where are we going to 6? So we're going from here over to here. What shape is this? It is a trapezoid. 1/2 times
2.
a height of
2.
Just like, why would we add 3? Because it says 3.
I thought we were just going in like order.
debating how I want to write this. What about if I say a height of -2?
That works. That's what I was thinking.
Why am I saying a height of -2?
Because it's
Because it's on there.
Because it goes below the x-axis. Now, you don't have to say a height of -2, but you are going to have to consider the fact that it's below the x-axis when we get there. Okay. What are my bases?
1 plus 3. Should those be -2?
Hold on. Okay, did you guys catch what I did wrong here?
Spaghetti.
Wait, no, I guess I didn't. Never mind.
Right.
I'm good. My height is -2. Oh my goodness. Okay,
And then it would be
1 plus 3.
1 plus 3. Yeah, I'm there. Okay. Sorry, my brain just got confused for a moment. What do we end up with here?
Negatives. Or -4.
Going for -4. Here's the deal.
What?
So if my trapezoid is this way now instead. which is where my brain, this is where I got confused for a moment too, so don't feel bad here, but the height is the distance between the parallel sides, which is the -2. My bases are the 3 and the 1. So, okay, now here's what I'm going to say. Do you have to think of that as a height of -4? You don't have to, but here's what you do have to do. What is this area? This area is a -4. Anytime you are below the x-axis, that area is negative. Doesn't matter, like the area can't be negative. Not in what we're doing here. Okay? Because we're below the x-axis. So we have negative values involved. Okay? So now 7 plus -4 is 3. Okay? So basically, area above the x-axis you're adding, area below the x-axis you are subtracting.
That triangle has
What? A triangle? Again?
area of -1.
Just 1.
It's
-1.
Okay.
It is negative.
We have a triangle, 1/2 times base times height. So numbers are 1/2, 1, and 2, but it is below the x-axis, so this is a -1. So we're going to say, oh, I guess I didn't fill this in, sorry. G of 7, 0 to 7, 3 plus -1, which puts us at 2. Okay, well, technically, that's part D down there, technically. Okay, so hold that thought. Okay, so A was complete the table of values for G. We did that. Okay, we're going to graph G at the very end. B is asking on what interval is G of X increasing?
0 to 3.
And why 0 to 3?
It's about the x-axis.
Okay, it is. It's above the x-axis. My values are increasing there, yes. Okay, we hit that point where it is.
Is that
Excuse
open or closed?
I have open in mind. Yeah. So G of X increases on the interval, and I have it written as 0 less than X less than 3. Can you also write it 0, like with parentheses? You can. I don't care which way you write it. Okay. So it is increasing 0 to 3. Where does G have a maximum value?
X equals 3.
Okay. X equals 3?
Yeah.
Okay. I thought I heard a question.
I heard 2.
Oh.
And I was.
I just heard 3, so am I?
Yeah.
Okay.
Heard 2.
Okay. So, yep. It has a max value. And here's the deal, guys. Why is that a max value? Well, A, it looks like it right here, but then what's happening on this graph? This graph changes from positive to negative, yes? So there's the other part that we can look at. Trying to think, how do I wrote down that G has a max value where F changes signs from positive to negative. Okay, so that's at X equals 3. If they say, where is the max value? It's at X equals 3. What is the max value? Max value is 7. You remember talking about that last semester? Okay, we talked about that. I think it was in Unit 5, where the max value occurs at X equals 3, but the max value itself is 7. Okay. And D says to sketch a graph of g of x. Now, we have information here for g of x, don't we?
Oh, yeah, for sure.
We have some inputs and outputs. So if you haven't already, put those ordered pairs on. First ordered pair is
0, 0.
then
1, 2, 2.
2, 5.
Yep.
3, 7. 6, 3. 7, 2.
Is it pointy or is it curvy?
More curvy is what I would have said.
Oh.
I-
I don't know.
it's not a huge deal either way, you know. Okay, I'm trying to think. Is there anything else on this page I need to mention? Okay. Did our answers to B and C pan out to be true now that we've sketched the graph? G of x is increasing from 0 to 3, yes. And there is a max at that point there. Okay, at 3, 7. Okay. Well, let's look at the next page.
2 pages down, where'd he go? And homework's only 4 questions.
I don't hate calculus.
It's only 4 questions. That's all.
Four
This class
pages.
period is just crawling by.
I was like, 4 questions?
Each question after.
Each question has their own page.
Okay. Okay. Which, by the way, okay. I always struggle on these days because I'm used to just glancing at the clock. Okay, we're not at 30 yet. We're not at 30 yet. Like, you know, I feel like, oh, we're still in A lunch here. Or I mean B lunch.
We get out at 0, 5.
Yeah.
0,
What?
Okay.
35, 11, 10, 11, 45,
Oh my gosh, you're
We
actually so
literally
right.
get
That's
out
such a way
at
to think of it.
115.
It ends
Yeah.
on 5.
I know. I'm just waiting for that longhand gets to 3.
Okay. Well, in that time, we're gonna talk about example 3. So let's examine what would happen geometrically to f of x equals the integral of, and that's there is a typo here. That 0 is not supposed to be a 0. It's supposed to be a k. I'm assuming yours has the typo mine has.
Yeah.
You know, I was thinking it did. So, okay, so f of x is the integral from k to x of f of t dt if we allow k to take on different values. That's the reason we have to have a k in the problem, don't we? Okay, so similar to some of we've already worked on, but taking a different direction here. So, given, oh, guess what? Same typo. Oh, wait, no. It's actually,
That was actually right.
yeah. Why do I have it crossed out in mine? No, it's not right. Because in example 3, k is 0. Well, no. Hold on. No, we've got to have, yeah. So we've got to have, that's why, okay. Yeah, this value has to be determined here. And in this particular problem, k is going to be 0.
So we'll always get a value there?
Well, yeah, you have to have something here because here, x is what's being provided. Am I making any sense?
Yes.
Sorry. I know, the typos in the book, I have to stop and process. Okay, wait, what was the issue here?
So what you're saying is that the first one isn't part of example 3.
No, but it's explaining the formula.
Right, it's just saying, okay, we're going to look at different variations of this. Okay,
So that's why that one's K and the other one is specific to the project.
and they're just flip-flopped is what they are. But okay, so complete the table of values for the function f, which is what's defined to be above. F is the integral from 0 to x of f of t dt, and we have an f of t graph. So, what do you got here?
0, 0.
This first one is going to be 0 to 0. What's f of x going to equal when we're going from 0 to 0?
0.
It's just going to be 0. Okay? And I'm not going to necessarily write out everything on the graph this time because we have some other pieces that will be going on the graph. But plug in 1.
What happened?
So we're going from 0 to 1. 0 to 1 is a little teeny tiny triangle,
Yep.
which is 1/2 times 1 times 1, so 1/2. Okay, 2. We're going from 0 to 2. What do you know 0 to 2?
A trapezoid.
So is it
Trapezoid?
You can make it a bigger triangle.
Ooh, that's true. That'd
Oh, I see what you guys, okay, thank you. That's what I was like, why are you guys saying trapezoid?
1 to 2.
Okay, I'm there.
That's what I was, yeah.
Okay, so we have options here. You could say, okay, we had a triangle here, now I have another trapezoid here.
That should be more.
Okay, or
I'm still counting.
if you catch it, how about just doing a triangle from 0 to 2?
That's easier.
Are we seeing this now?
yes?
Now, am I saying the trapezoid is wrong?
No.
No, not that. Now that I see where I was like, trapezoid, what are you guys seeing? I'm there. Both work, right? Okay, so what? 1/2 base times height. So from 0 to 2 is 2, yes? Okay, what about 0 to 3?
4.5.
Could you see just a bigger triangle? 1/2 times 3, so half of 9 is 9/2, or I agree with 4.5. Okay. 4.
I know.
What do you see from 0 to 4?
1/2, 4 times 4, which is 8.
Okay. Now, hold on. I'm not sure. I'm going to be. Okay. I'm not sure why, but we're going to keep going with this chart.
Is that part of
No, it just doesn't go far enough.
Okay, so let's do
It doesn't go far enough, in my opinion, to be able to answer questions B through I. Fair enough?
Fair enough.
The maximum value.
Yeah, because we start asking some of this, we don't have all the information. So we're going to keep going.
We got all the way to 10.
We're going all the way to 10. And why are we going all the way to 10?
That's where the graph stops.
That's where the graph stops. So 5, 6, 7, 8, 9, 10. However you want to do it. Okay, so where are we at with 5?
Now you have a triangle and trap.
Okay, so can we take the trapezoid and add on to our triangle? Or, well, no, I can't really do that. So what do we have here? 1/2, height of 1, and bases of 4 and 2. So that piece right there is 1/2 of 6, so that's 3. But what do we want to put at 5?
11.
We're adding it to the 8, so we're at 11. And you can write down as any pieces you want. I'm just trying to, What about
You have a small triangle from 5 and 6.
Okay. Or could we just have a big triangle from 0 to 6 if you really wanted to?
Oh,
I don't know if that's a better way to go necessarily. That's not what I'm saying, just so you know.
Well,
Let's do 12.
If you do the triangle from 0 to 6, it's half times 6 times 4. Okay. You could have done a triangle from 5 to 6, which would have added 1 on to what we already had, which was 11. So that's probably just as quick in this case. Okay.
Okay.
Wait. What?
What is it, height of 1.5?
Look at the exact one, too.
There you go, 1.5 plus 0. Or no, that's.
Why did I do that? Okay. Because, and I'm not sure why I did that, and I think it doesn't matter either way. I just have a dash here on my chart. I think I just didn't fill it in. I think I just didn't fill it in because
That's what we boxed it.
it's, yeah. And in all honesty, we get all the information we need with the other pieces. But if you think about the slope, this is down 3 over 2. So where does that put that? That does put that at 1.5, doesn't it? So you can do a triangle that's 1/2 times a base of 1 times 1.5.
what's that about?
So you end up at 3/4. So from 12, you're subtracting 3/4. So we're at, now, honestly, I would kind of forget that 11.25 for a moment and just, when we go to 8, can you just subtract off that triangle there instead?
Yeah.
It's going to be mathematically easier. Because this is a triangle of what?
3, 2.
1/2, 2, 3, so.
9.
Okay, 1/2 of 6 is 3,
That's negative.
and if you subtract 3 from up here, right, we're at 9.
Okay.
We're all in different spots here. Okay, and then for the same reason, I kind of have a dash at 9 because it got annoying, yes, and that's why I just went to 10. But if we do this, this is doable. If you do a trapezoid here, yes. So it's 1/2 times a base of 1, or excuse me, a height of 1, bases of 3 and 1.5.
Negative.
Yeah, there's a negative involved. 3 and 1.5 is 4.5. 4.5 is 9/2.
5.
So this is 9/4,
Oh, I'm just kidding.
which is 2.25. So if you subtract 2.25 off from 9, 6.75.
Yeah.
Now, I would go back and use the previous 9 and just that triangle, right? And if you don't like my idea, do your own. I don't care. What do we have? 1/2 of 2 times 3. So 1/2 of 6 is 3. Subtracting it from 9. Are we at 6?
Yep. I tried and it kind of worked a little bit.
It can work if you're careful. I mean, you get into some weird places, though.
We counted squares all the way up till 6.
Okay. And you were good up until then, and then when we hit the quarters, when you ran into problems. And I'm not going to say you can't count squares. There are times where, I mean, it's definitely squares. I'm thinking about the previous graph, but there's times where squares work. I get it.
Like, especially on that one, the first part, it's a slope of 1 over 1.
Yeah.
Which is half for all of it.
Yeah.
So,
I mean, yeah, you can tell that because of those slopes. So, okay. Domain of F. What is our domain of F?
0 to 10.
That's right.
Okay, so domain, what are your X's, your inputs, right? What are your inputs for capital F? And my inputs were 0 to 10. So 0 less than or equal to x less than or equal to 10. Or you could write it with brackets. I don't care. Okay. Use the concept of area accumulation, which is what we've been doing today, where we've been adding the area, accumulating the area. Okay? That's what we're doing. Because each of these times we were adding the previous area on, right? And that's what we did on our other graphs. Use the area concept of area accumulation to complete the graph of f. Plot the points in your table in blue.
Did we already do that? Or do we?
No, we haven't plotted the points.
Yeah.
So, if you have something you want from up here, go for it. I don't care. So,
I got you.
0, 0,
You got one.
1, comma half, 2, comma 2, 3, comma 4 and a half. Yeah, here's my blue that I'm using. 4, 8, 5, 11, 6, 12, 7, and this is where you don't necessarily have to graph the 7, but whatever. 8, 9, 9, 6, 7.5, 10, 6. Okay. You got it?
It's kind of like reminding me of our chemistry course.
Where is the 0 of f?
6 POI. 6, 12.
0.
Just kidding.
The graph we just graphed, which by the way, this is f, right? The 0 of f, where does it touch the x-axis? At x equals 0. Okay. What is the total change in f? When we talk total change is going to be the change from the beginning to the end. So at the end, we're at f of 10, which f of 10 is 6. At the beginning, we started at f of 0, and f of 0 was 0. And what is 6 minus 0?
6.
That is 6. So what is the total change?
6.
That is 6. How does the total change in f compare to the net area bounded by the graph of the function f and the x-axis?
Yes.
So total change is what we just found to be 6. Net area. What were we doing when we were creating this chart? We were accumulating the area, yes? We were finding the net area, the total area. What was the total area at the end?
6.
So what are they? They are the same. Okay, the total change and the net area are both 6. Okay. What is the maximum value of f?
12.
12. That happened at 6, right? Where does it occur?
X equals 6.
I really need to read the next question before I think out loud sometimes, right? What is the range of f?
0 to 12.
Okay. And if I write that as an inequality, it's 0 less than or equal to y less than or equal to 12 because it's talking about the range.
Okay.
No, sorry.
Okay, guys. I say that works, doesn't it? Okay, so we have what? 4 and 5 and 6 left to go.
No, that for
I got still got to do there.
I have to figure out. So we'll finish 6-3 notes tomorrow. I'm not here Thursday, so I have to figure out a plan for Thursday.
I'm not here Thursday.
I'm not here Thursday.
Can we just work on homework Thursday during class?
I don't know.
Unless we have a
So
It
you
was-
can't get out.
Okay. So, yeah, I'll figure it out. I kind of had some plans going on, but I just really decided I just kind of need to wait and see where we're at come Tuesday, Wednesday to figure out what I want my plan to be. So,
Is this supposed to snow tomorrow?
It's
it's
supposed
supposed
to
to snow later today,
tonight all the way from home.
but I don't think it's supposed to
That's supposed to be like as bad.
that bad, but I don't know.
That's the thing.
So,
If
yeah.
it sticks, then